Welcome back. Today we will be doing the word problems from the chapter Electricity. Here we have our first question. Calculate the number of electrons constituting 1 coulomb of charge. Charge on 1 electron, that is E is equal to 1.6 times 10 raised to minus 19. And this is the value which you should remember. Then according to the question, we have total charge, that is Q is equal to 1 coulomb. It's already given in the question, that is it's constituting 1 coulomb of charge. That is Q is equal to 1 coulomb. The number of electrons, we have the formula N is equal to Q divided by E. That is total charge divided by charge on 1 electron. Substituting the values, we have 1 divided by 1.6 times 10 raised to minus 9. By solving this, we get the value 0.625 times 10 raised to 19. Here we have taken 10 raised to minus 19 to the numerator and then it gets turned to 10 raised to 19. Then we have 6.25 times 10 raised to 18. Here we have our next question. How much energy is given to each coulomb of charge passing through a 6-volt battery? Energy given by the battery is equal to charge times potential difference. This is the formula. And we know that energy given is always equal to the work done. Energy is equal to the work done. So we have W is equal to QV. That is, Q is the charge and V is the potential difference. From the question, we have Q is equal to 1 coulomb. That is, it is given as each coulomb of charge. So we take each coulomb, that is 1 coulomb, and potential difference is 6 volt. 6 volt battery. In the question, it is 6 volt battery. So the potential difference is 6 volt. So we get the answer as 6 joules. Next question we have an electric lamp of 100 ohms, a toaster of resistance 50 ohms, and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. We have to find out what is the resistance of an electric iron connected to the same source that takes as much current as all the 3 appliances, and what is the current through it. From the question, we know that resistance of an electric lamp, that is R1, we take it as R1, that is equal to 100 ohms. Resistance of a toaster, that is R2, we take it as 50 ohms. And resistance of water filter, that is R3, we take it as 500 ohms. Now we have to find out the total resistance, that is equivalent resistance is taken as RP. Then equivalent resistance RP of the 3 appliances that is connected in parallel. We have in the question it is connected in parallel. So the formula is 1 upon RP is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And we have the values of R1, R2 and R3. That is 1 by 100 plus 1 by 50 plus 1 by 500. By solving it, we get it 16 by 500. That is, RP is 500 by 16 ohms. That is equal to 31.25 ohm. Now we have the resistance, that is 31.25 ohms. From the question, we have that the applied voltage V is 220 volt. And to find out current, we have I is equal to V by R. That is 220 divided by 31.25 ohms. So when solving it, we get the answer as 7.04 ampere. Then the next one. How can 3 resistors of resistance 2 ohm, 3 ohm and 6 ohm be connected to get a total resistance of 4 ohm and 1 ohm? So let's do the first one. We have to get the total resistance of 4 ohm. we can get a total resistance of 4 ohm by connecting the 2 ohm resistance in series with the parallel combination of 3 ohm and 6 ohm. That is, 3 ohm and 6 ohm resistors has to be connected in parallel, and with this the 2 ohm resistance has to be connected in series. So we have R is equal to R1 as it is connected in series. R1 plus the parallel combination, that is the second and the third resistors, that is R2 R3 divided by R2 plus R3. So we have 2 plus 3 times 6 divided by 3 plus 6, that is equal to 4 ohm, and here we have the answer 4 ohm. Now let's solve the second part. Here we have to have a total resistance of 1 ohm, and this is only possible when all the three resistors are connected in parallel. So we have the formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And the value of R1 is 2, R2 is 3, and R3 is 6. So we have 1 by 2 plus 1 by 3 plus 1 by 6. We get the answer 1 by R is equal to 6 by 6, and that is we get R is equal to 1 ohm. What is the highest and the lowest total resistance that can be secured by combinations of 4 coils of resistance 4 ohm, 8 ohm, 12 ohm and 24 ohm? So to find out the highest resistance can be obtained by connecting the 4 coils in series. So we have total resistance R is equal to all the 4 resistance is added up over here, that is 4 ohm, 8 ohm, 12 ohm and 24 ohm, that is equal to 48 ohm. This is the highest resistance that can be obtained. And the lowest resistance can be obtained by connecting the 4 coils in parallel. And for the parallel connection, we have the formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. All the 4 resistors, that is 4 ohm, 8 ohm, 12 ohm and 24 ohms. That is equal to 12 by 24. We want R is equal to, so 1 by R is half, 12 by 24 is simplified and we get the answer 1 by 2. So R is equal to 2 ohms. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. Here we have the charge as 96,000 coulomb. Then time given is 1 hour. So we have to convert this 1 hour into seconds. That is 1 times 60 times 60 seconds. We have the answer as 3600 seconds. Then we have the potential difference is 50 volt. It is given in the question that potential difference is 50 volt. So V is equal to 50 volt. Heat generated. Compute the heat generated. Heat generated, we have the formula H is equal to V multiplied by Q. That is the potential difference multiplied by charge. That is 50 volt multiplied by 96,000 coulomb. So we have the answer 4,800,000 joules. That can be written as 4.8 times 10 raised to 6 joules. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. It's a very easy question and we have the values over here. R, that is the resistance, is equal to 20 ohm. I, that is current, is equal to 5 ampere. And T, that is equal to time, that is 30 seconds. Now, heat developed. We have H is equal to I square RT. That is, substituting the value, we have 5I square, that is 5 square. 5 square is 25. So 25 times 20 times 30. That is equal to 15,000 joules, which can be written as 1.5 times 10 raised to 4 joules. When a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of that resistor. Here we have V is equal to 12 volt. Then I is equal to 2.5 milliampere. When it is converted into amperes, we have 2.5 times 10 raised to minus 3 ampere. We know that resistance is equal to V by I. That is equal to V is 12 volt and I is 2.5 multiplied by 10 raised to minus 3 amperes. So substituting the value, we have 12 by 2.5 times 10 raised to minus 3. That is equal to 4,800 ohms. So we get 4.8 times 10 raised to minus 3 ohm. Next we have a battery of 9 volt that is connected in series with resistors of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm respectively. How much current would flow through the 12 ohm resistor? Now to find out the total resistance, we know that R is equal to 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12 ohm. That is all added together as it is connected in series. So we have the answer as 13.4 ohm. Then potential difference is given as 9 volt. V is equal to 9 volt. We know that current, that is I, is equal to V by R. Substituting the value, we have 9 volt by 13.4 ohm. So by dividing 9 by 13.4, we have the answer as 0.67 ampere. Since there is no division of current in series, the current through the 12 ohm resistor is also equal to 0.67 ampere. How many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line? Suppose n resistors of 176 ohms are connected in parallel. So as per the formula, we have 1 by R is equal to 1 by 176 plus 1 by 176, and this will go on till n number of times. So we have 1 by R is equal to n by 176. So rearranging the formula, we get R is equal to 176 by n ohms. By Ohm's law, we have R is equal to V by I. So 176 by n, that is R, we have already got 176 by n. So 176 by n is equal to V, that is 220 volt. As for the question, we have V as 220 volt and I as 5 ampere. So 176 by n is equal to 220 by 5. So n is equal to 176 times 5 divided by 220. The answer is 4. Several electric bulbs designed to be used on a 220 volt electric supply line are rated 10 watt. How many lamps can be connected in parallel with each other across the two wires of 220 volt line if the maximum allowable current is 5 ampere? Now here we have current I is 5 ampere and voltage, that is V, is 220 volt. Maximum power, that is P, is equal to V times V, current multiplied by voltage. 5 multiplied by 220, we get 1100 watt. Now required number of lamps. We can find out the required number of lamps by maximum power divided by power of 1 lamp. So the maximum power, we have 1100 divided by power of 1 lamp is 10 watt. It's already given in the question, that is 10 watt. So 1100 divided by 10. So we have 110. So 110 lamps has to be connected in parallel. A hot plate of an electric oven connected to a 220 volt line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately in series or in parallel. What are the current in the three cases? The first case, when the two coils A and B are used separately, that is R is 24 ohms and V is 220 volt. Current I is V by R, that is equal to 220 volt by 24. V is 220 and R is 24. So we have the answer 9.167 ampere. Now for the second case, when the two coils are connected in series. So R is equal to 24 ohm plus 24 ohm, that is equal to 48 ohm, and V is 220 volt. Now we know that current I is equal to V by R. So 220 volt divided by 48 ohm. This is when we have to find out when the two coils are connected in series. So we get the answer as 4.58 ampere. Now for the third case, when the two coils are connected in parallel, we know that R is equal to R1 times R2 divided by R1 plus R2. So substituting the values, we have 24 times 24 divided by 24 plus 24, that is equal to 12 ohms. So the total resistance what we have got is 12 ohm. Now V is 220 volt. We know that current I is V by R. So here substituting the value, we get 220 volt divided by 12 ohm, that is equal to 18.33 ampere.